So let's talk about the field properties of complex numbers. The commutative property, and you know we have two of them, of addition, goes like this. 2 plus 3i, this is an example, plus 4 plus 5i is the same as 4 plus 5i plus 2 plus 3i. For multiplication, it also works. 2 plus 3i times 4 plus 5i is the same as 4 plus 5i times 2 plus 3i. So we can move the two numbers around. Remember, commutative means that we move the numbers for addition and multiplication, and nothing happens. The associative property, where we are concerned with grouping numbers together, we also have associative property of addition. If we have a plus bi and we're adding ci to it, we can also write a plus bi plus ci. And for multiplication, a I times bi times ci, we can equally write like this: ai times bi times ci. The distributive property, can we distribute a number that's on the outside of parentheses to the numbers on the inside? Yes, we can. A times b plus ci can also be written like this: ab plus aci. Let's talk about our inverse property of addition. If we have a plus bi and we add to it its inverse, which would be negative a minus bi, distributing we get a plus bi minus a minus bi, and that is 0. The inverse property of multiplication, if we have a plus bi and we multiply it by its reciprocal, 1 over a plus bi, we get a plus bi over a plus bi, and that is equal to 1. The identity property of addition, if we have a plus bi and we add to it 0 plus 0i, of course we will still have a plus bi. And the identity property of multiplication, a plus bi times 1 plus 0i. If we do this, then we will still have a plus bi. I changed the color there for you to make it a little clearer. Now let's get to the closure property. The closure property states that any operation on a complex number results also in a complex number. What that really means is, think about the real number system, right? we talked about taking the square root of a negative number, which is also a real number, right? And we weren't able to do that using the real number system. We had to create the imaginary numbers for doing this. But for the complex numbers, any operation we can perform on it, and we will still end up with a complex number. So we don't have to create and learn yet another number system. Promise, okay? So that looks all very confusing, but what I want you guys to take from this is this. All the properties that you have known, commutative, associative, distributive, inverse, and identity properties, work exactly the same way with complex numbers as they work with the real numbers, and you have learned those and you know those well. So there's nothing really new that's different or confusing. The only new thing is the closure property, and what it tells you is we got the imaginary and the complex numbers now, so no worries about any new number systems. So let's look at how we perform operations on the complex numbers, and the key to remember is when we do that, we treat I like a variable, although it's not really one, but we treat it as a variable, and then we simplify any powers of I. Let's add these two terms together. 3 plus 2i plus 5 minus 7i. So being able to use the commutative property, we can also write 3 plus 5 plus 2i minus 7i, which will give us 8 minus 5i. Subtracting negative 2 plus 8i minus 4 minus 3i. Let's be careful with all those minuses here, right? So we get negative 2 minus 4 minus, or rather we use plus because the 8i is positive, and actually the 3i becomes positive also because of the double minus. So we end up with negative 6 plus 11i. So when we multiply, we essentially do the same thing as FOILing two binomials. We multiply the first terms, the outer terms, the inner terms, and the last terms to get 15 plus 12i plus 10i plus 8i squared. We can go ahead and simplify this. 15 plus 22i plus 8i squared. Now remember, I squared is really the same as negative 1. So we got 15 plus 22i minus 8. Combine the 15 and the 8, and our final fully simplified answer is 7 plus 22i. To divide two complex numbers, we use something that's called the conjugate, and we use the conjugate of the denominator. So what's the conjugate? The conjugate is a term where our imaginary part of the number has the opposite sign of our original term. Let's look at it. And we take this to multiply by our fraction. So in other words, we have 1 minus I divided by 2 plus 3I. And we multiply this whole thing by a fraction that looks like this. 2 minus 3I divided by 2 minus 3I. Remember that new fraction has a value of 1. Numerator and denominator are the same, so we're allowed to do that. And what that does for us very nicely is it gets rid of our imaginary number I, or the whole term with it, in the denominator. So let's go ahead and multiply numerator and numerator, and then denominator and denominator. We get 1 times 2 is 2. 1 times negative 3i is negative 3i. Then we get negative I times 2 is negative 2i. And negative I times negative 3i is positive 3i squared. So that's a numerator. And the denominator goes 4 minus 6i plus 6i plus 9i squared. So each time where we have the I squared, we can replace that and make that a negative 1. And we get 2 minus 5i minus 3 in the numerator, and in the denominator we get 4 minus 9. Did I just say minus 9? It's of course plus 9, but why is it plus 9? Because in the previous step I should have said negative 3i times negative 3i is actually negative 9i squared up here. And so the negative times the negative gives us positive 9. Sorry about that. We continue to simplify, getting negative 1 minus 5i divided by 13. And since it's nicer to have the real number and the imaginary number part separated, we write negative 1/13 minus 5/13 I. Okay, now let's expand our last term. We got 2 plus 3i to the power of 3. And as you know, that's really nothing else than saying 2 plus 3i times 2 plus 3i times 2 plus 3i a third time. So how do we do this? First we multiply the first two terms using a foiling method that we have just looked at when we multiplied those other two expressions. And then the expression we get, we fully simplify and then multiply it by the third expression. I'm going to have you stop the video for a second and try that out yourselves, and you can then compare your work with my answer. Hopefully you got the same result. When we multiply 2 plus 3i with 2 plus 3i, we get 4 plus 6i plus 6i plus 9i squared. The 9i squared turns into a negative 9, remembering that I squared is negative 1. Combining that with 4, we get negative 5 plus 12i. Now we multiply that with the next term, and again, see, it's just another multiplication of an expression with two terms. Foiling, again, we get negative 10 minus 15i plus 24i plus 36i squared, which turns into a negative 36, for a final answer, negative 46 plus 9i. Hope you got this as well, and I will see you in class.